Okay, guys, good afternoon again. So we are following through with the transformation. So I take it that you studied the must know item that I told you to study. It's very important. I also take it that you watch over the video, you look back at the video, you know, to look at the minute details to ensure that you understand what we have done before or that we did yesterday. All right, so we looked at translation and we also looked at reflection. Those are the two that we looked at. Right, and there were some other things that we mentioned yesterday that is kind of general, like what the inverse transformation is and so forth. We also spoke about the matrices and how we need to memorize the matrices and know the matrices based on how the questions are set, and that knowing the matrices in particular will help us to know the answer to a question before we even do it. Right, so each student needs to ensure that they study that must know sheet for the transformation, and I gave you sections of it to study from yesterday. Today you're gonna get some additional sections to study. I don't want to rush it. I want to take time, so maybe I'll just do a few things today, and then on Wednesday we'll do some other stuff, such that we'll do that class activity we spoke about on Sunday. All right, so today we're looking at rotation. All right. And it's turning in a direction that is either clockwise or anti-clockwise. It is turning through an angle, normally expressed in degrees. So, for example, through 90 degrees or 45 degrees or 180 degrees. So it's turning through an angle, and it's turning about a center. So there's a center point that is not turning. That center point is called an invariant point under the rotation. So it's the only point that would not turn, that would not move under the rotation. So let's look at what the slide is saying. All right, so a rotation is a transformation in which every point on an object turns through the same angle, about the same, in the same direction. So the important things and are shown in the description of what rotation is. 3 components: angle, center, direction. So if you're going to describe a rotation, those 3 things must be mentioned. So I'm saying that from now, it's very important. You must state the angle of the rotation, you must state where the center of the rotation is, and you must state the direction. Direction is just anti-clockwise or clockwise. All right. So the center of rotation is the only point that does not change its position and is therefore called an invariant point. It's an invariant point. So we need to get familiar with that word, invariant. An invariant point of a transformation is a point that does not change, does not move on that transformation. So points on a mirror line, if you do a reflection, and that's a mirror line, points on a mirror line are invariant points because they stay where they are under the reflection in that mirror line. All right, so for rotation, the center of the rotation becomes invariant. All right, so anti-clockwise direction, this is general mathematics at any level. Anti-clockwise direction is usually given a positive angle, but you're not going to be using positive or negative angles at CSEC. You know? I'm just giving you this as information now, that generally speaking, in mathematics at any level that you do, the anti-clockwise direction is taken as a positive direction and is usually given a positive angle. And the clockwise direction is taken as a negative direction and is therefore given a negative angle. And it kind of strange because we would naturally feel that clockwise is the positive direction, but no. Clockwise is actually the negative direction in rotation, and anti-clockwise is the positive direction in rotation. But you're not going to be dealing with negative and positive angles, right? We're just going to be dealing with direction. So we might say 30 degrees anti-clockwise, or we might say 30 degrees clockwise. All right, so we're not going to get a positive or negative angle. So this is your information really. Okay, so I spoke about the components. So this slide is basically about that.
Sir.
Yes.
You can go back first so we can at least take a picture of the notes.
Why taking a picture of the notes and you have the handout? It's in the handout. It's in the handout, you know. Why taking a picture of something that is in the handout? That's why I give everybody have the handout. And I give you the handout so that you don't have to waste time writing because you have it there already. Right? The only thing I need is
Okay, you can go
students.
ahead.
The only thing I need is students to be writing are the solutions. Or if I write additional over here, that is not in the handout. But generally speaking, anything that is on this side, anything that is on the PowerPoint slide on this side, you have it in handout. All right, so you don't need to time and write that. All right, so let's continue. So the components, I'm saying here that 3 components of rotation must be stated when you're describing rotation. And you see that in the must know sheet. You must state the 3 components. If you describe a rotation and you leave out one of the components, you're not going to get the marks. You're not going to get the full marks. You must state the 3 components of rotation. There are 3 things happening in a rotation. Direction, there's an angle, and there's a center. And if you're describing a rotation, you must state all 3. All right, so that is one of the most important things for rotations. For example, in this one, I'm saying in this one that the line OA is rotated 25 degrees to the line OA prime, and the rotation is taking place about the point O. So what we have here, we can see the angle is 25 degrees. We can see the direction is anti-clockwise, and we can say that the center is the point O. So any statement that includes those 3 things, right? The angle, the direction, and the center is sufficient. Some persons will simply list them. All right, list the 3 components. We can put them in a statement. So the angle must be stated, the center must be stated, and the direction must be stated. And so if I'm describing this one that I'm showing in the diagram, I would say something like OA is mapped onto OA prime by an anti-clockwise, that's one component, that's the direction. Rotation, you must also give the name. So it's understood that you're also going to give the name of the transformation if you're describing it. And you're going to give the angle, so rotating to 25 degrees about the point O. So the 3 components are there in red, and the name of the transformation is there underlined. So you're going to give the name and components of every transformation. If you're describing a translation, for example, let's look back at it. So let's say we have triangle. Let's say we have a triangle. And the triangle undergoes a translation and move from here to up here. And the triangle moves up here. And I'm using this point as my reference point. And let's say the triangle go 3 units this way, and it goes 4 units that way. In describing this transformation, I have to say 3 units to the right and 4 units upward. So I would say the image triangle, the object triangle is mapped onto the image triangle by a translation. This would be a translation. 3 units to the right, 4 units upwards, given by T equals 3, 4. So the name of it, which is translation, and give the components of it, which is the how many units left or right, how many units up or down. If I'm describing a reflection, so I have the reflection now. So I have this line, and the line is y equals x. And I have a point here, P, and I reflect over the line to a point here, P prime. P prime. Right? Then this is reflected to this by a reflection in the line y equals x. That's all you would say. P is mapped onto P prime by a reflection in the line y equals x. So when describing a reflection, you have to state the mirror line. You state the mirror line. Those are the first 2 that we in the notes, it's in the handout, in the must know sheet. When we come to rotation now, and describing a rotation, you're gonna say the rotation are for, like in this example, A is mapped onto O prime by an anti-clockwise rotation because the direction is anti-clockwise through an angle of 25 degrees, and you're giving the angle about the point O. The thing persons tend to forget to include in the description in this is the center. People tend to include the center of the rotation. Right? People tend to state the direction, they tend to state that one, and they tend to state the angle. And for some reason, they tend to forget the center. Right? Let us not let that happen to us. Always describe it fully. Give the angle, direction, and the center, and you also give the name. All right. So what are the properties of rotation? Properties of rotation is pretty obvious, as for example shown in the diagram. So the object distance from the center equals the image distance from the center. You can see that here. It's almost like common sense. The distance from here to this point is the same distance from the center to that point. All right, almost like common sense. That's the first one. Second one is that the rotation angle is the line joining the point. So what they're basically saying is that the center of the rotation is on a line. Angle of rotation is the angle between the line joining point. Let me show you. Point to center to point. That's what that means. The angle of rotation, you can see it there. Point to center to point. The angle form there, which is what we're seeing here. A or A prime. And that's also pretty obvious. So this is nothing to really say you want to try to memorize, because it's almost like common sense. Right? So the angle of the rotation is at the center of the rotation, and it's the angle between the line joining the center to the 2 points. Angle between lines joining the center to the 2 points. All right. Basically, that's that. How do we find this? How do we find the angle of rotation? I'm going to skim through this quickly. And the reason I'm going to skim this quickly is that question that they said in recent times that is asking you to describe rotation. It's always very pretty obvious, because they tend to give 90-degree angles. No longer are they setting the ones that you have to do in a construction. Right? I'm just still going to skim through this quickly to show you how you would do it if you need to construct. Believe me, in the last maybe 20 years, they have not set any question where they're asking you to do any construction. They tend to put the rotation on a graph, and you can see the angle of rotation is usually 90 degrees or 180 degrees, and you can also see. But I'm also still going to show you a quick way to confirm that the angle is 90 degrees or 180 degrees or whatever. All right, but how would you do it? Construct to find the center, and then you have to measure to find the angle. That's the two basic steps if you're trying to find the center of a rotation or find a rotation, the angle and the center of a rotation. You construct to find the center, and then after you find the center, you measure to find the angle. All right, that's what you have to do. So the center of the rotation is on the perpendicular bisectors of two of lines joining corresponding points. I'm going to show you what I mean by that. That's where the center is located. Right? So the center of rotation is on the perpendicular bisector of line joining corresponding points. And so we always use 2 points, 2 perpendicular bisectors, to find the center. 2 perpendicular bisectors to find the center. So what will be the steps? I'm skim through it quickly and show you. So you choose the 2 points that you're going to use. You draw the lines joining corresponding points. You construct the 2 perpendicular bisectors. Where the 2 perpendicular bisectors meet is the center of the rotation. And after you find the center of the rotation, then you measure the angle. Point to center, the corresponding point gives the angle of rotation. Let me show you in a demonstration, and you can look back at these notes to see exactly what I'm talking about. All right, I'm going to do an example. So let's look at this now. Let's say I have that triangle right there. And that triangle is rotated to form onto another triangle. Right? The triangle ABC is rotated onto triangle A prime, B prime, C prime. So it goes through a rotation. And what you want to do, you want to find the angle and the center. You want to find the center and the angle of the rotation. So the point, the thing is that you have to find the center first. The center is on the perpendicular bisector of the lines joining corresponding points. All right, so let me show what I mean by that now. So that's a line drawing the corresponding points, A to A prime. And I say I need two of them. So I join another pair of corresponding points. I can use C and C prime, or I can use B and B prime. In this example, I use B and B prime. So I'm going to draw another line joining corresponding points. Then I need a perpendicular bisector of those two lines. What's a perpendicular bisector? Perpendicular bisector bisects the line and is also perpendicular to the line. So the perpendicular bisector of AA prime, I want the perpendicular bisector of B prime. Let me say it again. The perpendicular bisector, it passes through the midpoint of the line and is also perpendicular to the line. So let me show the perpendicular bisector of AA prime. So I find the centers first, and then I draw the two perpendicular lines through the center. Not the center, the midpoint. I find the two midpoints first, then I'm drawing the perpendicular of the lines through those midpoints. That's one of them. That's the perpendicular bisector of AA prime. That's the perpendicular bisector of BB prime. So you construct that. Where those two perpendicular bisectors meet, that's where the center of the rotation is located. And so I can mark that point here as my center point O. So now that I've found my center, I can construct to find the angle, because what it would mean, for example, is that this point C is rotated about here over to this point C prime. So this angle of rotation is that. Or I can use another point, A. So the point A is rotated over to the point A prime. It's the same angle. Or I could use point B. Point B up here is rotated over to the point B prime, and that's the same angle of rotation there. We usually use a point that is convenient. Yes, and this one I might want to use C and C prime, like that. Or A would be good as well, A and A prime. B kind of make it cumbersome, so I could use those two. But since we're talking about A prime, let's set it up like that. So I'm using A and A prime. So the angle between OA and OA prime is the angle of the rotation. And clearly the direction is clockwise. It's pretty obvious that this was rotated clockwise onto this. It's pretty obvious. So the direction will always be very obvious. All right, you can look and see what the direction is. And so that's my angle of rotation. And just use your protractor and you measure that angle. That will be an angle. In this case, I'm saying it is 40 degrees. And so if I want to describe this rotation now, I have to give the angle, the direction, and the center. I'll give the angle, the direction, and the center. And so I could say something like that. Triangle ABC undergoes a 40 degrees clockwise rotation about the point O. And so I've written the description differently this time, but I've still included the angle, direction, and the center. And this is the name of the root of the transformation. That's the name of it. So I give the name and I also give the components. All right, but as I'm saying to you, you'll hardly have any that you need to do like this. Right? I mean, over the last 20 odd years, they have not set any like this. They tend to put them just on graphs, and those tend to be very easy. You can look and see them. I'm going to practice a lot of questions and you'll see it. So this might be the only time you see us having to construct to find a rotation like this. All right, so don't worry too much about it. Maybe our master, the ones that would run graph, we can come back and spend some time on ones like this. But it's pretty straightforward, pretty obvious. All right, very easy, I should say. All right. So what are the rotation matrices? I introduced them yesterday. The rotation, the matrices. I showed you the clockwise one and the anti-clockwise one. Now, the important thing is that these matrices are matrices for rotating about the origin. It's an important thing. So if a rotation is taking place about a point that is not the origin, you have to do it a different way. You cannot use this one. All right? So this is for rotation about the origin. About the origin. All right? That's an important thing to note. These matrices are when the center of the rotation is the origin. All right? So let's look at those matrices now. So the common rotation matrices about the origin are, what are they? The clockwise 90-degree rotation matrix. I showed it to you yesterday. It's easier to just know it than have to work it out. That's it. With the negative one down here. Pay attention to the details. The anticlockwise one, the anticlockwise 90-degree rotation matrix is that one. So these are the matrices that will actually rotate the points on an object through 90 degrees, clockwise and anti-clockwise. All right, these are the matrices that will calculate it for you. So for example, if I have a point 5, 4, and the point 5, 4 is rotated clockwise 90 degrees about the origin, and I want to know where that point is going to go when I rotate it, I can use the matrix to work it out. 0, 1, negative 1, 0. And I multiply it by the 5, 4. And then I work it out. So it will be 0 times 5 is 0, and 1 times 4 is 4. So that will be 4. So the x value at the new point will be 4. And then it will be negative 1 times 5 is negative 5. 0 times 4 is 0. That will be negative 5. So it means that if I rotate this point, 5, 4, clockwise, it's going to go to 4 negative. That's what it means, you know. So if I were to sketch it on a graph to show it, all right, and I have a point 5, 4. So my point 5, 4 is here. 5, 4 is here. When I rotate it clockwise, 90 degrees, it's going to come down to 4 negative 5. So let's say this is 4. It's going to come down to 4 negative 5. Negative 5. So it's coming down to here. So what you see is a clockwise rotation. So like this point rotated 90 degrees to this point. So the rotation right here is 90 degrees clockwise. Right? So this point over here rotated 90 degrees clockwise, and the rotation took place about the origin. That's how it works. So this point up here is 5, 4, and this point down here is 4 negative 5. And so the matrix will do the calculation for us. So they say the matrix represents a clockwise rotation about the origin. That's that one. That's the first one. So this matrix represents a clockwise rotation about the origin. And this one represents anti-clockwise 90-degree rotation about the origin. These matrices will perform the rotation for you. And you need to know these matrices. You need to know these matrices. You can construct some of these rotations, but it's best to just learn the matrices. A question will ask you for them. All right, and we're gonna see some questions where we need to know them. We're gonna see later on where if we know these matrices, then we can know what the answer for our question will be before we even do it by knowing these matrices. So it's very important that we learn these matrices. So that is what that one will do. And I don't try to memorize these, because these can be worked out easily once you know the matrix. So I don't try to memorize those. Those can be worked out easily. So I'm going to show you one more time how you can work them out. Right? The first one, for example, I have the matrix 0, 1, minus 1, 0, and I'm using a general point xy. And I want to see what that general x point will go to if I rotate it clockwise 90 degrees about the origin. So it will be 0 times x and 1 times y. So I am getting y right here. And then it will be negative 1 times x and 0 times y. That's negative x. Negative x. What that means? That means that a point xy under a 90 degrees clockwise rotation about the origin, about O, about the origin, about O, the origin, will go to y negative x. So I can use any value. So my values are 3, 4. I know that 3, 4 under the same 90 degrees clockwise rotation about O. So the Y value comes to the front, right? You can see that, right? You can see that the Y value here goes to the front. And so that same thing happens with this Y value, it goes to the front. So you get in the 4 there. And you can see that the X value changes sign and goes second. So it changes sign and it goes second. Right? So we can do that here as well. This X value will change sign and go second and become -3. And so you can use the general point to work it out, right? But believe me, you won't have to do all of that with these questions. You won't have to do all of that, right? And guarantee it's just building on the information, right? All right, so the other kind of transformation, rotation, is the 360 degrees. Now, 360 degrees is actually the identity matrix. Nobody can tell me why a 360-degree rotation will be done by the identity matrix. Nobody can tell me why.
Because it's just going to go back into the same place.
Exactly. It's going back to the same place if you rotate something 360 degrees. And remember the identity matrix. Mute your mic, mute your mic, mute your mic, mute your mic. Mute your mic. Remember that identity matrix. Remember that the identity matrix is just like the number 1. So it's not going to cause any change if you rotate something 360 degrees. And so the identity matrix is what will do that for you. And so a point XY will go back to XY, basically. So that's a very good answer. And then we all know the 180-degree rotation. 180-degree rotation, as we said, is that one. -1, 0, 0, -1. Remember, it has the y-axis reflection. It has a y-axis reflection, -1 in it, and the x-axis reflection, -1 in it. Both of them in it. All right, that's a 180-degree rotation. And it doesn't matter the direction. 180 rotation, clockwise or anti-clockwise, is the same matrix. If you rotate something 180 degrees this way, you get that. I rotate it this way, it's going to get that. So it doesn't matter the direction. The clockwise 180-degree rotation is the same as the anti-clockwise 180 degrees rotation. And as we said, it is the same as reflecting through the origin. Same as reflecting through the origin. All right? Same as reflecting through the origin. Right there. All right? Same matrix for reflecting through the origin. I'm going to look late, yeah? Yeah?
For the 360 degrees matrix, I mean for the rotation. Yeah. Would we put A prime beside of the original A or
yes, yes. Very good question. There are questions where when you carry out a transformation, like for example, yes, that's a very good question. There are questions where, for example, you have a triangle, like suppose I have a triangle, and let's say this is a mirror line. Let's give you a quick example. And I have points on the mirror line, like a triangle like this on the mirror line. Right? And it have 2 points on the mirror line. So this is A, say B, C. Ask me for the image of that reflection, image of that triangle and a reflection in the line M. I know it's going to be like this. So this is going to be B prime, this is going to be A prime, and this is going to be C prime. So A prime and C prime is the same. C prime, C and C prime is the same point. A and A prime is the same. So yes, there are questions where a point and its image is the same point. But because CSEC don't know that you know, they ask you for the coordinates of A prime. But you just have to give them back A prime as the same point as A and label it as well. So there are questions where the image and the object is the same point. Object and the image is the same point. So that's a very good question. You have to label the same point with both letters. Label it A and also label it A prime as we did here. And here, this point here, we label it C and we also label it C prime. There are questions like that. And we're going to see that when we start doing examples. So that's a very good question. Very good question. All right, lovely. Show that people starting to think. Nice. All right, so let's continue. All right, so these are the matrices. Here again, I'm showing how you could calculate it, but really and truly, I prefer for you to just learn and know the matrices than to have to calculate. So I'm not going to spend any time on this. I showed you how to do the reflection it's the same way we do the rotation. Use a point on the axis and use a point on the x-axis. So you are using 1, 0 on the x-axis and you're using 0, 1 on the y-axis. And you call the matrix A, B, C, D, just the same. And it is because you know what the result will be. Let's look at it. For rotation, to find, so let's say we want to find the matrix R for a 90-degree clock rotation about the origin. Look at it. We're putting on what we know. Clockwise 90 degrees rotation. What do we know? It is pretty obvious. If I rotate this point clockwise 90 degrees, it's going to come down to here. And that point is 0, -1. So this point will come to 0, -1. If I rotate this point clockwise 90 degrees, it's going to go down to here. So this point will go down to that point. All right, so we know that. So because we know the result of those rotations, that's a premise on which we can actually calculate the matrix. All right, so let me erase this and show you. So it is actually on the slide. So see there, that point down there, if you rotate it 90 degrees clockwise about O, remember the O. Remember the center of the rotation is the origin. So it's like you're rotating this line down to here. All right, so that's that. So we know the result. Next one is that that point is going down to there. So you know the result of rotating those points. Because you know the result of rotating those points, you're going to use those points to help you to find the matrix. Here it is. We're calling the matrix A, B, C, D. And we're going to write that. You know that 1, 0 is mapped onto 0, -1 when we rotate clockwise 90 degrees. And we know that 0, 1 is mapped onto 1, 0 when we rotate 90 degrees. So what it means is that the matrix multiplied by this point is equal to this point. And again, the matrix multiplied by this point is equal to this point. Or you apply the matrix, the rotation matrix, you multiply the matrix by the point. That's how you apply the reflection matrix, the rotation matrix, the enlargement matrix. 2 by 2 matrices, transformation, 2 by 2 transformation matrices are applied by multiplying them by the point. That's how you apply them. So because you don't know what the matrix is, we're calling it ABC as I have here. And I'm saying you would multiply by the points. And you set what we call equality of matrices. So that's the first one. So the first one is where now I am multiplying this matrix by this point, and it is equal to this point. That is what I have here. Right? And then I run it as an equality of matrices. That's why we have to do that topic in matrices. Here. And when we do it, it tells us that the A equals 0 and the C equals -1. They do it again for the other 2 points, like that. Because one point is going to give you the 2 of the values, and the other point is going to give you 2 other values. So here it is now, we are doing it for the other point, which is a 0, 1 onto the 1, 0. And that's going to tell you the other 2 values, the B and the D. And then once you have the A, the B, the C, and the D, then you know the matrix. And that is the matrix for the clockwise 90-degree rotation. Better to just know it. How I know it? Let me show you how I know it. How I know it is like this. Each of them have 1 negative. So I draw the matrix. Put the arrow up this way, meaning that I want an anti-clockwise 90-degree rotation. That's telling me the -1 is at the top. For the anti-clockwise 90 degrees, as simple as that. That's how I remember it every time. And the 1 is down here, 0, 0. That's the anti-clockwise rotation. So if that's the anti-clockwise 90-degree rotation, the clockwise one must be where the negative is down here now. And the one up here. And then this is 0 and this is 0. So this one is for the clockwise, like I'm saying that the -1 is down there. 90 degrees clockwise. So I remember this first. Once I remember that one, then I automatically know this one. That's how I remember it. That's simple. I don't have to go through all of this calculation to find it. Right? CSEC won't ask you to work it out, you know. They just ask you to write it down. We show that in the last class. I don't have to waste time and do it in the exam. Why? I can do these 2 matrices over here. Easy. Come on, man. If you can know it, if I can know it, you can know it too. All right? So I don't expect anybody to have to depend on this calculation to find the matrices. And there's not 1 million matrices. We're talking about 4 lines. Y-axis reflection, x-axis reflection, y equals x reflection, y equals minus x reflection, and then reflection to the origin, which is the same as a 180-degree rotation. That's the lines, you know, that's the lines for reflection, you know. Then we'll come to rotation, talking about a clockwise 90-degree rotation, which is this one down here, clockwise 90-degree rotation, 90 degrees about origin. Anti-clockwise 90-degree rotation about origin. 360-degree rotation is the I matrix. That does make sense. So it's I matrix for 360 degrees, 1, 0, 0, 1. And trust me, you're not going to get any calculation to do with that. It's just information. The questions that you're going to get are for this one, and for the 180 degrees one. They like to give questions with the 180-degree rotation, which is minus 1, 0, 0, minus 1. They like to give those three you're getting. Right? You're not going to get this one in the question to do as rotation. No, you're not going to get that one. You're going to get the clockwise 90-degree rotation matrix, the anti-clockwise 90-degree rotation matrix, and you're going to get the 180-degree rotation matrix. Remember, the 180-degree one doesn't matter whether it's clockwise or anti-clockwise. So some questions will say clockwise, some questions will say anti-clockwise, no matter. But the 180 degrees is the same matrix. Same matrix. And remember, this matrix is the same as reflecting through the origin. Reflecting through the origin. So why waste time and study this over here? But I waste time and learn that, man. You don't need to use it. There's no need to actually use it in an exam to prove the matrix and just know the matrix. All right, so I'm depending on you guys to just learn those matrices. Are very easy. In the handout, take your time and learn them. All right, so the next slide really is to do the other one. Oh, the next slide I only did one. So the same method for the other one. All right, so we'll come now to inverse rotation. Common sense. What's the inverse of a clockwise 90-degree rotation? Somebody tell me. What's the inverse of a 90 degrees clockwise rotation about the origin?
Sir,
What's the inverse?
Counterclockwise 90 degrees rotation, sir.
Exactly, about the same angle. Exactly. So if you rotate 90 degrees clockwise, I want to go back to where you're coming from. They rotate 90 degrees anti-clockwise. So the inverse of a clockwise 90-degree rotation, the anti-clockwise 90-degree rotation about the same center. So the inverse of a rotation is a rotation in the opposite direction to the same angle about the same center. So an inverse of rotation is easy. I told you, I told you the inverse of the transformation is easy, The inverse of the transformation means like common sense. Inverse of the translation, easy. Go back in the opposite direction. Inverse of a reflection, easy. Just reflect back over the same line. So if you reflect over one line to go somewhere, and want to go back the other way, just reflect back in the same line. Go back the other way. The inverse of a rotation is just rotate the opposite direction in the same angle and use the same center. Common sense. All right. So basically, that's what this is saying. The inverse of an anti-clockwise rotation is a clockwise rotation about the same center to the same angle of rotation. The inverse of a clockwise rotation is therefore an anti-clockwise rotation about the same center to the same angle and about the same center. Yeah, about the same center and to the same angle. So if you were to calculate the inverse, if you calculate the inverse of this matrix, actually calculate it. But this one is the anti-clockwise 90 degrees rotation. Minus 1 up here, 1 down here, 0, 0. If you calculate the inverse of this matrix, you calculate the inverse of it. You're actually going to get this matrix, The minus 1 down here, So if no one can do it because it is the inverse transformation. Trust me, the inverse of this matrix is this one. And vice versa, the inverse of this matrix is that one. Vice versa. All right? Makes sense. Because if I rotate clockwise 90, anti-clockwise 90 degrees, and I want to go the other way, if I use this matrix to do a transformation, and I want to reverse it, I have to use this matrix to reverse it. All right? So those two matrices are inverse of each other. If you calculate them one over the determinant times the adjoint, you're gonna get the other one from between those two. All right. So that's a common sense in this thing. All right. All right. So this thing we're looking at now is very important, guys. CXC set a lot of questions on this. In the last class, I told about two reflections over parallel lines. CSEC said question on that twice in the last 20 years, 2 times. Two reflections over parallel lines. That's what we did in the last class. We had 2 parallel lines. All right, let me show you. The last class, we spoke about 2 reflections over 2 parallel mirror lines. So like you have a triangle here, so, and you reflect it to come here, so first. And you reflect it again, it goes here, so. No, I'm not drawing that on properly. Reflect it again. It's gonna go here, like this. Keep drawing it wrong. Try it properly. I'm gonna go like this, like that. And what we said is that to go from this one straight to this one is a translation. So it's a translation. And the distance of a translation is twice the distance. The distance between these two is d, and the distance of a translation is 2d. That's what we said in the last class. But that's when you have 2 parallel mirror lines in the last class. So when you have 2 reflections over 2 parallel mirror lines is equivalent to a translation. And the translation direction is perpendicular to the 2 mirror lines. And the distance of the translation is twice the distance between the 2 lines. That's what we did in the last class. CSEC said question on the parallel lines 2 times in the last 20 years. You see the intersecting line ones that we're going to look at now, 2 reflections over intersecting lines, they set that almost every year. But they don't set it directly, no, they set it indirectly. And that is where your knowledge is going to help you now. Because the question is set indirectly, right? It's like the setting questions where there have been 2 reflections over intersecting lines. But they don't tell you that's what they're doing, but that's what they're doing. And that's how I can know what the answer is going to be. I know what happens when you have 2 reflections over intersecting lines. And that's how the questions can be easy. So I needed to learn this. If you know this, guys, more than likely you'll be able to solve your transformation questions. Very, 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 very easy. I'm going to show you how to spin to it later. I'm not ready yet. I'll show you the basics first. So this is it. So 2 reflections over intersecting lines is actually equivalent to a rotation. Right? 2 reflections over intersecting lines is equivalent to a rotation. Rotation takes place about the point of intersection of the 2 lines, and I want you to add something to this slide now. Add something to it for me. The angle of the rotation is twice the angle between the 2 lines. Right? The angle of the rotation is twice the angle between the 2 lines. So 2 reflections over intersecting lines is equivalent to a rotation about the point of intersection of the 2 lines, and twice the angle. Twice the angle between the lines. Now, what do I mean by twice the angle between the lines? So if the angle between the lines, let me show you what I mean before we move on. If I have 2 mirror lines and they intersect at this point, 2 mirror lines and intersect, so it's mirror line 1, mirror line 2. So I'm not talking about parallel lines now where they intersect. I'm talking about 2 lines that are not parallel and they intersect. And I have an object here, and I reflect it, come here, and then I reflect that again, it's gonna come down here, gonna come down here. So I do this first, and then I reflect in this one to go there, right? So it's 2 reflections that took place. So it's this one to this one first, over that line, and then this one to this one, reflecting over this line. What I'm saying to you now is that to go from this one to the start to the end is equivalent to a rotation about the point where the 2 lines meet. And if the angle between these 2 mirror lines let's say the angle between these two mirror lines is 30 degrees. Then my rotation angle is going to be twice as much. It's going to be 60 degrees. That's what I'm saying. Two reflections over two intersecting mirror lines is equivalent to one rotation. The rotation, the center of the rotation is at the point of intersection of the two lines, and the angle of the rotation is twice the angle between the two mirror lines. So because the angle between these two mirror lines is 30 degrees, then the rotation angle is 60 degrees. Now let me tell you what they like to do in CSEC now. I'm telling you from now, before we even get into it, I'm telling you from now. What I like to do in CSEC, right, is give you this. I like to give you a reflection over the y-axis, for example, and then a reflection over the line y equals x, for example. So that's what, let me show you what they like to do in CSEC. They like to give you two reflections and say, okay, this point reflect over the y-axis to this point. So this is P and this is P prime. And then from P prime, you do a reflection over this line now, y equals x, to here. This is P double prime. So I did two reflections over these two lines, this one and this one. What's the angle between those two lines? What's the angle between this line and the line y equals x? What's the angle between those two lines on a graph? And where the y equals x goes right down the middle between the y-axis and x-axis. So what's the angle between those two lines? These two lines, the y-axis and line y equals x. What's the angle between them, guys? Somebody can tell me what's the angle between those two lines, the y-axis and the line y equals x. What's the angle between them?
45 degrees.
45 degrees. Simple as that. 45 degrees. Yes. So the angle between them is 45 degrees, right? And you did those two reflections. What are we getting? We are getting, mute your mic back, mute back your mic, mute back your mic, mute back your mic. Then what we are saying is that to go from this first point to this last point, all we need to do is do a rotation. A rotation this way. What will be the angle of that rotation? This is the center of rotation is the origin now, you know. Center of rotation becomes the origin. What will be the angle of that rotation? Since the angle between the two lines is 45 degrees, what will be the angle of the rotation? Unmute the mic and tell me.
90 degrees, sir.
90 degrees. 90 degrees is the angle of rotation. So that will be a 90 degrees clockwise rotation, don't it? Now look at what we did. Everybody pay attention now. Look at what we did. We did a y-axis reflection. We did a y-axis reflection, don't it? We did a y-axis reflection. And we know the matrix for our y-axis reflection. It's -1, 0, 0, 1. Right? And then we did a y equals x reflection. We did a y equals x reflection. I'm showing you how to combine the matrices that you're going to use, you know. That's why you have to learn them, you know. Now, y equals x reflection. Y equals x reflection is this one. One that looks at the identity matrix 0, 1, 1, 0. I will put those two together, and both of them becomes equal to a 90 degrees clockwise rotation. And what's the matrix for a clockwise rotation? 0, 1, -1, 0. So they're using up three matrices that we are supposed to know. One question. Let me tell you a question like this right now. Question will tell you, say, for example, do this y-axis reflection first and tell you what the point is, P prime. In part two of the question, we say, okay, reflect P prime now in the line y equals x and get the point P double prime. And then the third part of the question now is a killer now. Third part of the question will say, what single transformation will take it from P to P prime? That is where the knowledge of this now comes into play. Because if you already know that two reflections over intersecting lines is equivalent to a rotation, then you will know that because those two lines are 45 degrees apart and they intersect at the origin, then you're actually getting a rotation of 90 degrees about the origin. All right? And then you'll also know the direction is clockwise based on where the points are. You know the direction is clockwise. And then because you know the 90-degree clockwise rotation matrix about the origin, part 4 of the question will say to you, write down the matrix that represents this combined transformation. And then be the answer, combined transformation. Or they might ask you to calculate it. I can tell you from now, it can be calculated. Let me just tell you something. I'm kind of going ahead of myself, but I just want to show you how knowing the matrix is important. This can be calculated from these two by doing what? Multiplying the second one by the first one. What they say is that you apply the second transformation to the first one. Just like we're doing functions, I would say f of g means g followed by f. It's the same thing in transformation, right? So the compound or the composite transformation or the compound transformation is this one. If I multiply the second one by the first one, I'm going to get this. So I'll show you. If I multiply the 0, 1, 1, 0, the second transformation, multiply by the first one, I'm going to get this. So the question will ask you to do this calculation, but this is how I tell you that you know what the answer is going to be before you do it. I know that the answer is going to be this because I know this over here. So I know that the answer will be this before I even do it. So let me just calculate and show you now that I'm sure that you're actually going to get it. Right? Let me just calculate and show you now. And you work them out in the same way as you normally work out the matrices, right? So remember now, is rows of the first matrix by the columns of the second matrix. Right? So see it here? See it here? So this value times this value is 0, and this value times this value is 0. So the first value there is 0. And then the value over here now is this row times this column. So what is it? It's 0 times 0 and 1 times 1. 1 times 1 is 1. See there? 1. Then the value down here now is this row times this column. So 1 times a negative 1 and is 0 times 0. The 1 times negative 1 is negative 1. Negative 1. And then the value over here now is going to be a 0 because it's this row and this column. So it's 1 times 0 and 0 times 1. That value is there is 0. So I knew that the answer was this before I do the calculation. That's the point. I tell you that transformation is a topic that you can know your answer before you do anything. When you know stuff like this, guys. Because I know that 2 effects by intersecting lines is equivalent to a rotation. The rotation angle is twice the angle between the lines. And I know that because one line was the y-axis and one line was the line y equals x. Those 2 lines are 45 degrees apart. So the rotation angle that I'm getting is a 90-degree rotation angle. Also, the 2 lines meet at the origin right here. So the center of my rotation is the origin. And I know 90-degree clockwise rotation matrix about the origin is this one. This one. And then I also know that if I want to get a single transformation from 2 transformations, I multiply the second one by the first one. So I know what the answer would be before I did the calculation. So I just kind of went ahead of myself a little bit. So everything that I showed over there is eventually going to come up in the slide. But I'm showing the importance of learning matrices and also knowing these things. These things that are over here, the importance of knowing it and make it stick in your brain and understanding it. Because these are the things that help you to know the answer to questions before you even. All right, but let's continue. As I've sort of gone ahead of myself. All right, but no problem, no problem. All right, so I wanted to write that the angle of rotation is twice the angle between the lines. Very important. Twice the angle between the lines. And if we continue to demonstrate it on a diagram, what is happening here? So I have these 2 mirror lines, and I have that triangle. And the 2 mirror lines intersect at that red dot down there. So I'm going to do the first transformation, which is a reflection to there. And I'm going to do the second transformation, which is a reflection to there. And what I'm saying is that to go from the first triangle to the second triangle, let's put on another diagram. The first triangle to the second triangle, I can do a rotation instead about the point of intersection of the two lines. And then the angle between the two, the rotation angle is twice the angle between the lines. So you can put this on this diagram as well for me. So put the angle between the two lines as theta, put it on for me. Put it as theta right here. Let's say that angle is theta. Don't know what theta is. Let's put the rotation angle in blue now. I'm going to change the color and put the rotation angle in blue. So the rotation angle would be 2 theta. So the angle between the two lines is, and the rotation angle is 2 theta. So if the angle between the two lines is 30 degrees, rotation angle is 60 degrees. If the angle between the two lines is 40 degrees, rotation angle is 80 degrees. If the angle between the lines is 35 degrees, then the rotation angle is 70 degrees. When I understand that? When I understand that?
Yes, sir.
Very important that you understand this, guys. It's on the must-know sheet. All right, and I want to take some time and actually study it, and I'm sure you know it. All right, so that is that. Very important for you to know this. All right, we're gonna see the application of it in some questions. All right, so let's continue. All right, so I also told you that a 180 rotation about a point is the same as reflecting through a point. And the reason for this now, the reason for this thing right here is that sometimes you get questions where they want you to actually do a construction of a rotation, a 180-degree rotation through about a point. Instead of trying to do the 180-degree rotation about the point, instead of trying to actually construct this, instead of actually trying to construct this part, let me go again. Instead of trying to construct this part and 180-degree rotation, because the question will tell you about a 180-degree rotation about a point, and they tell you to construct the rotation of, for example, a triangle. Instead of trying to construct the rotation of a triangle, it's better you do this. Reflect it through the point. Reflect it through the point, the center point of the rotation. But these two things give you the same result. This one is hard to do. This one is easier to do. So this one is harder to do. This one is hard to construct. This one is easier to construct. This one is easy to construct. So no matter waste time trying to do this instead, because it is easier and the result is going to be the same. That's what this is about. All right, and we're going to see it on exam possible questions where they ask you to do rotation about points. Remember, I know this is when the center of the rotation is not the origin. If the center of the rotation is the origin, then you could just use the matrix -1, 0, 0, -1 and do a calculation. I'm talking about when the center of the rotation is not the origin. This is when the center of rotation is the origin. So when the center of rotation is the origin, you can just use the matrix origin. You can just use this matrix and do your calculation. Or when the center of rotation is not the origin, some other point, then that is when you have to actually do this construction. All right. So let me show you. A 180-degree rotation about a point is the same as a reflection through the point. All right. When we do a class activity, we're going to see an example of this. And I hope you can remember to do it that way. All right. So we're going to use image distance from the point equal object distance from the point. Right? And the image is going to be on the other side of the point because it's just a reflection. All right, using a diagram. Let's say I have this point P as my center point, and I have that point A to do a 180-degree rotation. That's my 180-degree rotation about that point. That's it. So I go from A to A prime by doing a 180-degree rotation. Let's look at it again. I'm going to do a 180-degree rotation about the point P, rotating the point A about the point P. So I rotate it over like that. Everybody can see it rotated. 180-degree rotation. I'm saying instead of doing a 180-degree rotation, in particular, if for example you have a triangle to do it with, it is better you reflect through the point. Look at the second diagram now. I'm going to reflect through the point like that. Reflect through the point. The result is the same. And I use the object distance equal the image distance. So I just draw a straight line to the point. I measure the same distance from the object point to the center. from the center to the image point. The two things is equivalent. Two things is the same. These two things basically are the same. So it don't make no sense to try to do this one. Don't try to rotate. Better you do the reflection. Easier to do the reflection. Do this. Don't try to do that. That is the point. All right, because the result is the same. All right, but understand that we're gonna see a question where we have to do a rotation 180 degrees, and I'm saying it's easier to just reflect through the point. All right, so let me see what time it is now. All right, it's now 4:30. All right, let me start my size transformation, enlargement transformation. All right, I'm gonna do the enlargement transformation, and I'm gonna leave the compound transformation for Sunday. All right, through size transformation now, enlargement transformation. I want pay attention to the details of this now. All right, so remember the correct name for this enlargement transformation or the size transformation is really this enlargement transformation. So you're not going to see this on the exam paper. Almost will never see that on the exam paper. This is where you're going to see the word enlargement. But the reason I tend to put size on the handout is because I want you to know that whether the thing gets larger or smaller, the name of it is still enlargement. All right, the name of it is still enlargement, and it's represented by the letter E normally, E for enlargement. So most times when they're given an enlargement question and I want to represent the enlargement, they use the letter E. All right, that's what they normally use. So this is it. An enlargement now is a transformation which maps a shape onto a similar shape, which is either larger or smaller. All right, so it's either the shape, either the thing gets larger or the thing gets smaller. Doesn't matter. It is still called an enlargement, and it takes place about a center of enlargement, and it uses a scale factor. So the scale factor really is just like a multiple factor. It tells how much larger the thing becomes. It's a factor. So for example, the scale factor is 2, but the sizes are not twice as large. The object now is twice as large. If the scale factor is a half, then it reduces in size and becomes half the size. There's one additional thing that takes place that people tend to ignore, and that if the scale factor is 2, then the image is also twice the distance away from the center. So not only does it make it larger, it also makes the distance away from the center twice what it was. If the scale factor is a half, it gets smaller, but also it will halve the distance from the center of the enlargement. So the center of the enlargement is almost like a light source, and you're casting a shadow using the light and shining the light on an object, and the object is casting a shadow on a wall. So think of it like that, and then the image on the wall is the image of an enlargement if that image gets larger. All right, so think of it like that. So the center is like a light source, and you want to produce a shadow, and you want the shadow to be larger, all right, than it was before. Let's get into it. So remember now, there's a center of enlargement and there's a scale factor. So we can say it from now. If you're describing an enlargement, you have to state those two things. If you're describing an enlargement, you have to state the center of the enlargement, and you also have to state the scale factor of the enlargement. If you're describing an enlargement. Enlargement has two components, a scale factor and a center. And you have to state both of them if you're ever describing an enlargement. So if you're doing a transformation, you see something was this size, and the image is this. No guessing. That's an enlargement transformation. Once there's a change in size, the transformation is an enlargement. If it was this, and the image is that's an enlargement transformation. No guess and spell, it's an enlargement. So you need to find where the center is, and you need to find the scale factor. So when I look at how we find the center, look at how we find the center, the scale factor. How we find the center and how we find the scale factor. Very easy stuff. All right. And most times you can actually look and see. So let's say I have this object, triangle ABC, and I have that image, A prime, B prime, C prime. it means that that transformation is an enlarged transformation. What I need to know now is where is the center of the enlargement, and also what is the scale factor of the enlargement. In other words, what do I multiply the sides on the small triangle to get the large triangle? What factor do I multiply this by? What factor do I multiply? That's called a scale factor. What's my multiplying factor? Go from the size of this one to the size of that one. And also the distance from the center. So how do I locate the center? To locate the center, all I need to do is join the corresponding points and extend the corresponding points until they meet. So for example, I join A and A prime with that red line. And then I join B and B prime. See where those lines meet right there? That's where the center of the enlargement is. And then I join again those points as well. So most times I only need to use 2 points, but I'm just showing it with all 3 this time. So it means that where those red lines meet, those are my lines joining intersect corresponding points. B corresponds to B prime, A corresponds to A prime, and C corresponds to C prime. Where those points meet, where the lines joining those points meet is the center of my enlargement. So as I said, it is like this is a flashlight shining on this triangle and casting a shadow on a wall, and the shadow is larger than the object, right? So this is like a light source casting a shadow. So the center is like my light source. This enlargement, clearly this is my invariant point that doesn't change, right? So this point change to here. This point change to here. This point change to there. The center don't change where it is under the enlargement. So that's my invariant. Invary. Does not vary. Invariant point. So the word kind of makes sense. It does not vary. The invariant point. All right. So the O will be my center of my enlargement, and then I want the scale factor. So if I want the scale factor, for example, remember it would go. I'm going to show you quickly. It would be AB times some factor equal A prime B prime. So we can set it up. AB times some factor K equals A prime B prime. So therefore the K will be A prime B prime divided by AB. If I divide AB and here, right? That's it. So if you look at it, it's my image distance divided by my object distance. That's my center of my enlargement. And then that's it, what I'm saying there. Scale factor times AB equal to A prime B prime. And therefore, if I divide by the AB, I get that the scale factor is A prime B prime divided by AB. So it's an image distance divided by the corresponding object distance. Right? This is an image distance because it's a distance on the image. This is an object distance because it's a distance on the object. My scale factor is an image distance divided by an object distance. And it makes sense because I would have to multiply, see here, I have to multiply the object distance by the scale factor to get the image distance. So it kind of makes sense, right? Not kind of makes sense, it makes full sense. And therefore that's it. Also, not only are the sides on the object affected by the scale factor, the distance from the center is also affected by the scale factor. So the distance from the center to here is also multiplied by the same scale factor to get the distance out to here. So the scale factor is 2. The scale factor is 2. Then this distance out here, the scale factor is 2. Then this distance out here is twice the distance to here. Let's use the B. The scale factor is 2, then the distance all the way up to the B prime is twice the distance to here. Twice. The scale factor is 2. So the scale factor affects the distance in terms of the size of the object. It affects the size of the image and the object, but also it changes the distance from the center. People tend to forget that part of it, that it also affects the distance from the center. And that's what this last equation down here is saying. right? You can also use the distance from the center to get the scale factor. All right, very important, guys, very important. All right, so that is it. So the scale factor will always be equal to an image distance divided by an object distance. I'm saying displacement here because the direction kind of important. Why direction important? Because the scale factor can be positive or negative. Or we can actually, there's a way to know when the scale factor is negative and when the scale factor is positive. I'm going to tell you. So don't worry about the word displacement right now. Don't worry about the word displacement. Say distance for the time being. All right, we're gonna work out how the scale factor is negative. So let's use the word distance. Displacement is when you want to consider the direction. But as I said, I can show you a way to consider direction. All right, I'm going to show you how to get when the scale factor is positive versus when it is negative. A very easy way. All right, so let's continue. All right, so let's look at it now. I'm going to break it down now. So the size of the transformation is primarily dictated by the sign and the value of the scale factor. All right. The transformation or the enlargement transformation is primarily dictated by the value of the scale factor and the sign of the scale factor. When I say sign, I mean whether the scale factor is positive or negative. That's what I mean. All right. And when I say value, I mean like maybe 2 versus half. That's what I mean. Or 3 versus a third. Stuff like that. So the value and the sign of the scale factor will dictate how the enlargement takes place. And it's common sense. Believe me, a lot of this is common sense. Don't think of it as being anything difficult. Very, very simple. I'm going to show you how simple it is by giving you examples. All right. So say that the scale factor is greater than 1. Let's say the scale factor is 2. Now 2 is clearly a positive value. And the 2 means that it's going to get larger. It's going to get twice large. And also, it's going to go twice the distance from the center. So a scale factor of 2 will cause the image to be twice as large and also will be twice the distance from the center. But then because it is positive, what will happen is that the object and the image will be pointing in the same direction. And the object and the image will be on the same side of the center. So let's look at that. The image is larger than the object because the 2 make it get larger, twice as large, and is located on the same side of the center. This is what I wanted to add now. This is what I'm used to when it's positive. And pointing in the same direction, right? And pointing and pointing and pointing in the same direction. So the image and the object will be pointing in the same direction. That's when the scale factor is positive. So the size 2 makes it larger because it gets twice as large. Positive on the 2 cause them to point in the same direction. They are now pointing in the same direction, and both of them are on the same side of the center. Same side of the center. All right. So I want us to remember part of it. All right. That's what happens there. All right, by the time I finish all of them, you'll see. Don't worry yourself. All right, that's that happens. So let's do a diagram to explain, to show it. So let's say I have that image and I apply a scale factor of 2. Then it means that my image is going to be twice as large. So how do I locate my center again? Join the corresponding points. Join the corresponding points. So I join A and A prime, extend it. Join B and B prime and extend it. And so that's my center of my enlargement. Now, look what I mean by pointing in the same direction. When I'm in class, I'm able to show it easier. What I mean is that on the object, A is pointing up. On the image, A is also pointing up. On the image, on the object, B is pointing down. On the image, B is also pointing down. So the image and the object are pointing in the same direction. And next thing where I say both of them are on the right side of the center. Both of them are on the right of the center. That is why the scale factor is positive. That is why the scale factor is positive. So when the scale factor is positive, the image and the object will point in the same direction, and both of them will be on the same side of the center. For example, in this case, both of them are on the right of the center, and the points are pointing in the same direction. The points on the object and the points on the image are pointing in the same direction because the scale factor is a positive scale factor. It is larger because of the value 2, so it's twice as large. And also remember that the distance from the center is doubled. The distance from the center is also doubled because of the 2. All right, so these are the things that happens. All right, hope you understand that. As I said, by the time I finish it, you'll get the understanding. So that's the first one. That's the first one. All right, so let's move on. That's the first one. All right, so in this case, the image distance is twice the object distance. All right. In this case, the image distance is twice the object distance. So A prime, B prime is 2 times AB because of a scale factor 2. All right. And also the distance from the center, OA prime is 2 times OA. The image now is twice the distance away. See there, distance all the way up here is twice the distance to here because of the scale factor 2. Because of the scale factor. So not only is the image twice as large, the distance is also twice the distance away from the center of the enlargement. Very important. All right, moving along. OB is the same thing. The distance from O to B prime is twice the distance O to B. The scale factor push the image twice the distance away from the center of the enlargement. Let's look at another scale factor now. So let's say the scale factor is a fraction now, like half, or a third, or 3/4. A scale factor of a half means that the thing gets smaller. It's now half the size. In addition to being half the size, it's half the distance away from the center of the enlargement because of the half. And by now, the scale factor made the thing change the size of the thing and also change the distance from the center. Then, because it is a positive, this is actually a positive, scale factor, and a positive half, It means that the object and the image will be pointing in the same direction, and object and the image will be on the same side of the center. Either the two of them are on the right side of the center or on the left side of the center, or both of them are above the center, or both of them are below the center. Both the object and the image be on the same side of the center when the scale factor is positive, and you know when you see the two of them pointing in the same direction. But all you know is that the image is going to be smaller because of the scale factor of a half. It's going to be half the size, and also it's going to be half the distance from the center. So it's coming closer to the center of the enlargement because of the half. All right, so let's look at it. The image is smaller than the object because you're taking half the size, and is located on the same side of the center. I'm going to add this again, and pointing in the same direction. And pointing in the same direction. It's pointing in the same direction because of positive scale factor. Pointing in the same direction. When the scale factor is positive, the object will point in the same direction. Let's look at it. Let's look at it now. So that's my object triangle. And that's my image triangle. Is it smaller? So I'm going to locate the center now. Same way. Join corresponding points to locate the center. Join A to A prime, extend it. Join B to B prime, extend it. Look at it now. A is pointing up on this. A prime is pointing up. B is pointing down on the object. B prime is pointing down. Both of them pointing in the same direction. So therefore, the scale factor is positive. All right, the scale factor is positive. Bam, that's my center is. Both of them are on the left side of the center. See, this one is on the left, and the other one is also on the left of the center. Both of them are on the same side of the center. That's because this is a positive scale factor. But it is obvious that this one is smaller than this one because of the half. To being smaller, addition to being smaller, the distance from the center or to here is now half to here, because we're taking half the scale factor, so the distance from the center is cut in half. So the sizes are cut in half on the object to create the image. The distance from the center is also cut in half to get the image distance from the center. All right. So open body observing those things. All right. So these are the things you need to pay attention to. Let's look at the calculation now. Let's look at the calculation. See it here? The image distance, A prime, B prime. All right, image length on the object, A prime, B prime, is half of AB because of a scale factor. It is half. Also, the distance from the center is also half. So O to A prime is half O to A, and O to B prime is half O to B. That's what the scale factor does. Half the size and also half the distance from the center, because the scale factor is a half. Because it's a positive half, they are pointing in the same direction. All right, we're getting nicer now. Let's look at a negative 2 now. So look at a 2 already. Now we're looking at a negative 2. So let me tell you now. The 2, the value 2, is going to make the image get twice as large, just the same. And also it's going to be twice the distance of the center. That's the 2. That's what the 2 does. Now what does the negative do? The negative will now invert it so that the image and the object are now pointing in opposite direction. And also it's going to put it on the opposite side of the center. So now the center is going to be between them. So the object, if the object is on the right, the image is going to be on the left. That's how it works now. That's what the negative does. The negative inverts it onto the opposite side. The negative inverts the object and put it on the opposite side of the center. So the 2, the value 2, makes it as large and twice the distance from the center. But the negative now inverts it and puts it on the opposite side of the center. And then now they are pointing in the opposite direction. So if I see a diagram, and I know it's an enlargement because one is bigger than the next one, and when I look at the points, I see that the points are pointing in the opposite direction, then I know that the scale factor is negative. The scale factor is negative. All right, so let's look at it. So the image is larger. Why is it larger? Because of the 2. It's larger than the other, but it is inverted on the opposite side. Why is it inverted? Because of the negative. And you're going to this now. And pointing in the opposite direction. And pointing, write this now, and pointing in opposite direction. It's pointing in the opposite direction because of the negative. The negative caused the image to be pointing in the opposite direction. Let's look at it now. So that's my object. I'm going to apply a scale factor of negative 2 on this object now. See it, you know, bam. Look at it now. I see it bigger than it, you know. So the value of the scale factor is 2. But they are pointing in opposite direction. Let's look at it. The A is pointing down on the object. The prime is pointing. The B is pointing up on the object, but the B prime is pointing down. Look at it. This point when I have no letter pointing this way, and this point, the corresponding point when I have no letter pointing the opposite way, they are pointing in the opposite direction. So the two make it get twice as large, twice the size. That's what the 2 does. But the negative is what is causing the pointing in the opposite direction. And so it is inverted. So what is going to happen now? What's going to happen now is that the center of the enlargement is going to be between them, because we refer to locate the center in the same way. You have to join the corresponding points like that, A to A prime. And when you join B to B prime, same thing again. So you see that where those two lines join the corresponding points meet is now between them. So the image and the object are now on opposite sides. The object is to the right of the center. The image is to the right of the center, and the object is to the left of the center. They are now opposite sides of the center. So when the center is between them, the scale factor is negative, guys, negative. Everybody paying attention to these things. Pretty easy, very easy to know when the scale factor is negative. When they're pointing in opposite direction, the value 2 is what makes it twice as large, right? And also distance is twice. Look at the distance. The distance of the center is still twice. And look, this distance out here is twice the distance to this one. So the distance of the center is still twice because of the 2. The distance of the center is still twice, just that it is in the opposite direction. And because of the negative, it is in the opposite direction. The negative make it go in the opposite direction. All right. So negative make the thing come opposite direction. It's on the opposite side of the center, and they are also pointing in opposite direction. And the key word is that is it inverted. It is inverted. Inverted. It is inverted. Image is inverted. So rotate it now. Rotate it. It is inverted on the opposite side of the center. All right. It is inverted on the opposite side of the center. All right. So everybody paying attention to these details. All right. When you go, you can watch about the video and make it stick. And the information stick. That's what the negative does. All right. In terms of the calculation, it's the same for the calculation now. We already know that the scale factor negative, but no, in terms of the distances, in terms of the length of the sides, it is the same 2 times. The image length is still 2 times the object length in terms of size, in terms of distance. The negative is for the pointing in opposite direction. And CSEC asks that, and CSEC asks a question like, why is the scale factor negative enough? Scale factor is negative because the image is inverted on the opposite side of the center and pointing in the opposite direction. That's what they're going to say. They ask, why is the scale factor negative? The scale factor is negative because the image is inverted on the opposite side of the center and pointing in the opposite direction. They ask at CSEC, why is the scale factor negative? And that is what you have to tell them. All right. So that's it again. So the distance, B prime is 2 times the BA. If you notice, what I've done, I've switched around the letters. To account for the fact that the point in opposite direction. But technically, same length. So if this are 5 centimeters, then this is going to be 10 centimeters, basically, in length. Twice as long. Those are the point in opposite direction. Point in opposite direction because of the negative. All right. So same thing with the distance. Right. So OA is 2 times AO. Same thing again, because I'm trying to bring the direction into play here. But it doesn't matter. But I write OA or AO, I'm still talking about the same distance. I switch around the letters here just to show the change in direction because of the negative. All right, that's what that is. And the same thing happens with the B. OB prime becomes 2 times BO or OB. Same thing. All right, let's look at when the scale factor is negative half now. All right, let's look at when the scale factor is negative half. All right, ready now. So the scale factor is a negative fraction, like negative half, negative 3/4, negative 1/3, negative 1/4. The scale factor is negative fraction. All right, let's break it down now. The fraction, with 1 part at a time, the fraction is going to make the image half the size, smaller. So the size is going to be smaller. All right? Half the size and also half the distance from the center. So the size on the object is going to be half that on the image, sorry, is going to be half the size of the object. And also the distance of the image from the center of the enlargement is going to be half the distance of the object. But then know the negative is now going to invert it and put it on the opposite side of the center and then have the points pointing in the opposite direction. So the negative is going to put it on the opposite side of the center and cause the points and cause the image to be pointing in the opposite direction. So the center of the enlargement is going to be between them. If the object is on the left, the image is going to be on the right. If the object is above, the image is going to be below. Right? They're going to be on the opposite side of the center. So the center enlargement is going to be between them. All right, so let's look at it. See it more. Bam. The image is smaller. In this case, it's going to be actually half. The image is smaller than the object and is inverted. The key word to remember, guys, is that the negative causes it to be inverted. That's a key word to use. Inverted, not inverse. Look at it spelling properly. Everything important. It inverts it. It is inverted on the opposite side. Invert means that it's going to be pointing in the opposite direction. It is inverted on the opposite side of the center. I want you to add this for me now. Add this to the statement. And pointing in the opposite direction. And pointing. It's pointing in the opposite direction because of the negative. Pointing in the opposite direction. It's pointing in the opposite direction because of the negative. The negative causes it to be pointing in the opposite direction. All right, simple as that. So let's look at the diagram. It's going to be half the size. So we have that as our object. And now we have that as our image. All right, we have that as our object, and we have that as our image. Clearly, the thing is half the object, the image is half the size of the object. And you can see right off the bat, the A is pointing up, the A prime is pointing down. The B is pointing down, the B prime is pointing up. This point will have the letter pointing so, this point will have the letter pointing so. So they are pointing in opposite directions. So if I see that diagram, I know automatically that my scale factor is negative. I know that it is negative by virtue of them pointing in opposite direction. It's not a guess or spell things just so it go. Once the image and the object of an enlargement pointing in the opposite direction, the scale factor negative. All right, as simple as that. And then the center is going to be between them. Oh, we know. Join the corresponding points, A to A prime, and join B to B prime. Where those lines joining corresponding points meet, that's where the center is. Clearly there, the center is between them. Center is between them. Right? And you can see, in terms of distances, what is that then? The A prime, B prime is half the BA, or the scale factor value of a half. The value is a half, so it's half the size there. This image, this image length is half of this one. Half, just at the point in the opposite direction. That's why I've reversed the letters and that to show that the point in the opposite direction. But in terms of the physical length is half. This length was 8 centimeters, then this length will be now 4 centimeters because of the value half. Also, the distance is half from the center. So this distance is half this distance. So this distance was 4, and this distance is 2. The distance from the center is also half. Plenty of people forget about the distance on the center part and all the focus on the size and the object and the size and the image. The scale factor affects the distance center as well. Don't forget that. It's very important. The scale factor also affects distance from the center. It affects the actual physical size of the object and the image, but also applies to the distance the center of the enlargement. All right, and know that the scale factor is negative because they are pointing in opposite direction, and also because the center is between them, because the center of the enlargement is between them. So same thing that applies for the length applies on the distance from the center. Same thing for the B. Same thing for the B. All right. So basically that is it for this part. All right. That is it. All you need to summarize now over here. All right. But I think they understand what I've said so far. But I think they understand what I've said.
Yes,
Just need to go back and look at the video, make sure it says stick. These things are very easy. If the scale factor value is greater than 1, like 2 or 3, 1.5, 3.5, any value greater than 1, the value I'm not talking about now, not about the positive or negative now. The value is greater than 1, the image is going to be larger by that amount. If the value is a fraction, a value fraction like half, quarter, 3/4, any value between 0 and 1, then the image is going to be smaller, and the distance from the center also is going to be shorter distance from the center. If the scale factor value is a fraction, then we'll come to the positive and the negative now. If the scale factor is positive, the object and the image will be pointing in the same direction, and both of them will be on the same side of the center. So for example, if the scale factor is positive, then the image and the object, both of them will be on the right, or both of them will be on the left, and both of them will be pointing in the same direction. They will not be inverted. If the scale factor is negative, then the image and the object will be pointing in opposite direction. So the A pointing up, the A prime will be pointing down. The B pointing to the right, the B prime will be pointing to the left. They'll be pointing in the opposite direction, and they will also be on the opposite sides of the center. So the image is on the left, the object is on the right. That is when the scale factor is negative. So if a question asks you, and I give you a diagram, and just look at the diagram and you see that the image and the object point in the opposite direction. I also see the center in them. And the question is, why is the scale factor negative? Easy. The scale factor is negative because the object and the image are pointing in opposite direction, and they are, and you can say the image is inverted. Give them the fancy word. The image is inverted on the opposite side of the center. Same thing that I write here, that's what you write on the exam paper, and you're good. It's on the must-know sheet. Make sure you study it. If I don't, this additional thing on the must-know sheet, we're going to look at it later and you write it in if it's not there. Because this thing I'm putting in red is something that I amended over the years, because I find students understand it a lot better when I talk about pointing in the opposite direction. Easier to see that they are pointing in the opposite direction. And this is why I've added this to the slide. I don't add it physically to the slide yet, but that's why I put it there in red. I want to write it and pay attention to it, and also put it on the exam paper if they ask you why is the scale factor negative. I've seen them before. Them ask you why is the scale factor positive. You tell them the same thing, because the object and the image are pointing in the same direction, and they are on the same side of the center. That's when the scale factor is positive. They will be pointing in the same direction, and both of them will be on the same side of the center. Is either the two of them on the right side of the center, or the two of them on the left side of the center. One additional thing to remember is that the scale factor also affects the distance from the center. So the distance of a point from the center is 2, and you apply a scale factor of 5, the distance is going to go to 10. 2 times 5 is 10. So the scale factor affects the size on the object itself, and also affects the distance of the object from the center. Plenty people forget that part of it, that it affects the distance from the center, the scale factor. All right, so let us go and do the summary page. This is the summary page right here. It says if K is positive, the image is on the same side of the center. You're going to add this to now and pointing in the same direction and pointing in the same direction, right? That and pointing in direction and pointing in same direction. Write it on the slide. Those of you have the hand or you have the booklet, write it in there. Those of you have the booklet, write it point in the same direction. If the scale factor is negative now, reach your so now. The next one. If the scale factor is negative, the image is inverted. Make sure you give them that word when the scale factor is negative. The image is inverted on the opposite side of the center and pointing, give them this as well, pointing, we're pointing, the opposite direction, pointing in opposite direction. It's pointing in the opposite direction. We're talking about the relationship between the image and the object now. Opposite direction. When the scale factor is negative, they will point in the opposite direction. So you can look at the diagram, know what the scale factor is without actually calculating anything. Just look and know. That's why I love transformation so much. You can know your answer without doing any work. You look on the diagram and you see them pointing in the opposite direction. And you see it's negative. And you see one side twice as large as the next one. You know, says negative 2. Done. All you need to do is find the center. Or you find the center. Join the corresponding lines. Point to point. Point to image. Point to image. Point. Where they meet of the enlargement. Easy. Easy. This one now. This means the value of the scale factor. That's what this means. This modulus of K means the value of the scale factor. That's what it means. So for this one, if the value of the scale factor is greater than 1, so like for example, this means like this one means example. This one means example. Example K equals 3. And this one, the scale value of scale factor is less than 1, means like a fraction. That's what I mean by that. That means the value of scale factor is less than 1, meaning like fraction. So example for this one now. Example for this one. Where is it? Example for this one. Is K equals a quarter, or a half, or a third, or 3/4. That's what that one means. So this is the example. This one up here. This is the example for this one down here. When the scale factor is a value like 3 or 1.5, any value greater than 1, the image is going to be larger than the object. When the scale factor is a fraction like a quarter, or a half, or 3/4, or a third, any value less than 1, the image is going to be smaller. So the value affects the size. The positive or negative affects the direction where them point, and also decide if them on both of them on the same side of the center and opposite sides of the center. So scale factor, 2 parts of a scale factor you need to consider. You consider the value of it and also the sign of it, signing positive or negative. And these is a summary of how these things affect the relation between an image and an object of an enlargement. Right. Go back and watch the video. I've said everything I need to say. So anything I miss you, I listen to the video carefully again. Pause it, listen to it, make notes. Make sure you understand what I've said. There's one thing I know I can do is explain things good. And I know that I explain good. So if you still not get it fully, go back and listen to the video. You will understand it. And you get it even better when we start doing questions. Mute your mic, please. Mute your mic. You'll understand it even better when we start doing the questions. Because we're going to do questions. Right? I just want us to go through the notes first. Right? Finish the notes first. And then we'll do the questions. And you'll see that this thing is really very easy. It's the easiest topic in maths. Transformation. Because you can know the answer of a question without doing anything at all. Just look and know what the answer is by just knowing some stuff that is on the must-know sheet for you to know. All right. So finish. I'm going to finish off with the enlargement today, and we're going to come back right? When I come back, do the other stuff, right? When I do some compound transformation and stuff. That's what's on the next slide. The next slide is find the center and scale factor of enlargement. This is like common sense. I show you how to find the center already, and the scale factor will be very obvious. It's just how large the image is over the object. So the image divided by the object. Let's look at it. Right? So to find the center, measure to find the scale factor. Similar to how you find the center of a rotation. Right? So the center is on the line, the center of enlargement is the point of intersection of lines joined corresponding point. We've been doing that all day. Right? I extend the line if necessary, and we use 2 lines. Let's look at this example, at the steps. Use 2 points, basically. Let's use 2 points. Right? That's what this is saying. Trust me, I don't even want to spend too much time on this because it's kind of irrelevant. Kind of what we're going to do is like common sense. Trust me, believe me, it's going to be common sense. All right, so let's say we have that object and we have that image. Before we do anything, let me ask some questions. So this one, is a scale factor a fraction or a whole number? Answer. Huh? Look at which one is the object and which one is the image. Look at it. The image is the one with the prime. The image is the one with the prime on the points. Object is the one with no prime. See that?
Fraction.
It's a fraction. See there, this one smaller than this. This is a fraction of this. It has been reduced in size. Right? See that this one is the object. That's the original thing. And this one is the image. The image. Because of the prime that is on the point. And the prime that is on that point. That has prime that's on that point. The image is the one where carry the prime letters. So this one come before this one. This one go to this. So it goes. So summation go. So it's a reduction in size. So this is a fraction of what it was. So scale factor clearly is a fraction. So you couldn't get a scale factor of 2 for this, or a scale factor of 3. You must get something like a third or a quarter or a half or 3/4, something like that. But understand that. Next question, is the scale factor positive or negative? Would the scale factor be positive or negative for this one? Unmute the mic and tell me. Or negative scale factor?
Positive.
Good. All you have to do points pointing. This point B pointing so, this B pointing so. Point in the same direction. C pointing so, C prime pointing so. That's enough. The points are pointing in the same direction. A pointing down so, A prime pointing down so, A and A prime pointing down so. So the corresponding points are pointing in the same direction. See it? This is not inverted. If you're pointing in opposite direction now, then you would know that the scale factor is negative. See that B a point, so A to B so, A to B is the same way. So write the subunit of the scale factor positive. Positive scale factor. And it's a fraction. So I'm supposed to get a positive fraction. Next thing, where would the center be? Center gonna be between or on one side of them?
On one side.
On one side. Exactly. When the scale factor positive, both of them gonna be on the same side of the center. So it can't be this up. When the scale factor negative, the center is in them. Let us get these little images in our minds. The more things you know that you don't have to figure out in an exam when you're doing transformation, it is your transformation questions are. And believe me, not a lot of things. Not a lot to know. You know these things, the question just gets easier and easier and easier. And the thing about it is that they're asking the same things all the time. They might give you different shapes, different points, different, but it's the same things they're asking all the time. Most of the questions we're gonna see that it's the same things they're asking all the time. Just make sure you learn the things on the must-know sheet. Make sure you take the time and actually know the things on the must-know sheet. I'm going to show you how you apply them, that knowledge, when we start doing the questions. Right? Transformation is supposed to be a full marks question on the exam paper. Full marks for your transformation. And the beauty about it, you can get 2 transformation questions on one paper, you know. One in section 1, which is basically one way constructing with a diagram. And one in section 2 where you do calculating with matrices. You can get 2 transformation on the same paper. 2 transformation questions. Transformation questions are also all over the choice. You want to crush it. Crush the transformation. It's too easy. Way to make it easy is to study the items on the must know sheet. Make sure you know them like that. Take some time and study them if you're really serious about this exam. When I ask you anything on that no sheet, you will be able to tell me just like that without even thinking. That's the level of knowing that I'm talking about. Know the matrices, know some of the combinations that I'm going to tell you. Know so with scale factor negative, they'll point in opposite direction. Know that if the factor positive, they'll point in the same direction. Know so the scale factor is a fraction, the thing gets smaller. Know so the scale factor is a whole number, the thing gets larger. Know that the scale factor also affects the distance from the center of the enlargement. You'll be able to look at the diagram and know what the scale factor is, positive or negative, without doing any calculation at all. I tell you, sit in your head, your brain tell you. Just look and know what it is, and you just answer the questions. And you know what the answer is supposed to be before you even do it. You know what the answer is supposed to be. So like you write the question. But you have to take the time to learn things I'm telling you to learn. Trust Mr. Shah, and you have no problem in this exam. I'm telling you. Just do what I tell you, and you'll be safe in this exam. Just do what I tell you. Just do what I tell you. Study the items on the must know sheet. Make sure you know them. I'm going to show you how you apply them. Start knowing them now. Right? Know those little rules. Learn the matrices. Learn which matrices for reflection requires. Over y-axis, one for x-axis, one for reflection line y equals x, one for reflection line y equals minus x. Learn the 90-degree clockwise rotation matrix, the anti-clockwise 90-degree rotation matrix, the 180-degree matrix. Learn that 2 reflections over parallel lines is a translation twice the distance between the lines, and the direction of the translation is perfect with the direction of the lines. Learn that 2 reflections over intersecting lines is equivalent to a rotation. Center of the rotation is the point of intersection of the 2 lines, and the angle of the rotation twice the angle between the lines. Know those things, and the questions will be a breeze. Trust me when I tell you that. You will know the answer to the question before you even do it. So they ask the question, and you know where your answer going to be, and you just need to show them, say, do it and get your marks. You know what the answer is going to be. I'm telling you. You know, you have to continue with this. So we're going to find the center of the enlargement by joining the corresponding points. See there? Join A, B, and B prime, and join A and A prime. Extend where those points meet. That's the center of the enlargement. This was a graph paper. This was a graph paper that was on graph paper like so. And this was y-axis, and this was x-axis. You will see where that point is on the graph. Maybe to be the point 1, 2, or 2, 1, something like so, or 2, 2, 1. It will be the point 2, 1 on graph paper. You know the center of the enlargement is 2, 1 on graph paper. Bam. Next thing we want to find is the scale factor. So measure a distance on the object and measure a corresponding distance on the image. So if I made a mistake in the let's say I make a mistake and put 12 over 3. Because I know that my scale factor is a distance divided by a corresponding distance. Let's say I make a mistake and put 12 over 3 and get 4. I know so that can't write. Because my scale factor has to be a fraction because the thing gets smaller. So it can't be 4. 4 is when something gets bigger. So I know it can't be 4. So I know that that's a mistake. That's why I'm saying you have to have these preconditioned things in your head. Thing gets smaller, scale factor is a fraction. My answer have to go be a fraction. Can't be a number greater than 1. Have these things in your mind, you're going along that route, so you're helping yourself along the way. Don't just get answer and write it down when it makes sense. So I know that to be wrong. Can't be 4. has to be a fraction. Somebody realize I make a mistake and put the wrong one on top of the wrong one. It has to be the image divided by the object. The image divided by the object. Let's look at it. See there? An image distance divided by a corresponding object distance. The image distance is 3. See there? This is the distance, is 3. A distance on the image, corresponding distance on the object. If I knew distance from here to here, I could have compared that one with this one as well. Distance from the center could be used. You're gonna get the same scale factor if you know those two distance. I'll have to put this one over this one, distance from the center, because that gives a scale factor as well. Distance from the center. Scale factor affects the distances on the object and on the image in the same way that it affects the distance from the center. Distance from the center. Very important. Right? So you have to learn how to use the information that you have by having all this knowledge. So my scale factor is that. Now that I know my center and my scale factor, I can give my description. Because to describe an enlargement, you have to give the two components of the enlargement. The two components of enlargement, the center and the scale factor. So if I'm describing an enlargement, I have to state those two things. Must state the two of them in my description. All right? Everything important. Everything important. So that's my description. Triangle ABC undergoes an enlargement of scale factor 0.25 about the point O. See, I've given the name of the transformation here, and the components are the scale factor and the center. By saying about the point O, I'm saying that O is the center. That's what we say when something is a center. I say about the point O. So let's say a rotation about a point. I can say an enlargement about a point. That's another way of saying that the center is the point O. When you say about the point, an enlargement about the point, a rotation about a point. That point is a center enlargement, or that point is a rotation. When you say about the point, that's a nice way of saying it right here, about the point. But if you want to say it's an enlargement, the scale factor is 0.25, and the center is the point O, you can spell it out like that as well, no problem. If you want to say scale factor is this, center is that, no problem. Good enough. All right, good enough. All right, always say. Very good so far? Very good?
Yes, sir.
So next thing we're going to do now is enlargement matrix. And this enlargement matrix is the matrix that will do the calculation for you. The important thing for the enlargement matrix is that it is for enlargement about the origin. When origin is the center of the enlargement. See there, that's what it says. The matrix for enlargement is a scale factor K about the center, about the origin. O, the origin is that matrix there. K0, 0K. All right, and it's very easy. I'm going to spend a lot of time on it. But the matrix for enlargement. So you just put the scale factor right here. So factor is a half, you put it right here. So scale factor is 2, you put it right here, so same here. Scale factor is -2, you put it right here, so same here. Scale factor is -half, you put it right here, so same here. Whatever scale factor is, you put it right here. K0, 0K is the enlargement matrix. Remember, that's when the center of the enlargement is the origin, the point 0. The center of the enlargement is some other point. You cannot use that matrix. You cannot use the enlargement matrix. You have to do some form of construction. See questions like that. They give you an enlargement to do, or the center of the enlargement is not the center, it's not the origin. So you cannot use that matrix. You have to do it by construction. You're going to see questions like that later on. All right? So how that works, simple. You're basically multiplying the coordinates by the scale factor. So the scale factor is 2. So for example, let's look over here. If I have a point 3, 2, and I want to carry through an enlargement of scale factor 3, scale factor K equals 3 about the origin. Make sure I put in about origin. About origin. Then I just multiply origin. Then my image, if this is A, then my image A prime, let's multiply the values by 3. Simple as that. And it goes to 9, 6. That's why I apply the factor of 3. Multiply the values by 3. That's what this is saying. If K were here, you can see it. If the point is K, if the point is X, and apply an enlargement of scale factor K, and multiply this by K. And multiply that by K. Simple as that. Multiply by the scale factor is -3, multiplied by -3 is -0.5, multiplied by -0.5. Remember, it is when the center of the enlargement is the origin. You can do that. Very simple and straightforward. Inverse of an enlargement. All right. Suppose somebody tell me now. Suppose I carry out an enlargement of scale factor 2 about the origin. An enlargement of scale factor 2 about the origin. Common sense. What will be the inverse of that enlargement? An enlargement of scale factor 2 about the origin. What will be the inverse of that enlargement? The inverse. Common sense. An enlargement of scale factor 2 about the origin. That enlargement of scale factor 2 is going to make something get twice the size and push it twice the distance away from the origin. Tell me, what would be the inverse of that enlargement? The man can tell me somebody.
So,
yeah.
KY, comma.
No, man, don't give me no values. No. Tell me just tell me in words. What is the inverse of an enlargement of scale factor 2 about the origin? If I apply an enlargement of factor 2 about the origin, what will be the inverse of that enlargement? In other words, what transformation is going to take me from the image back to the object, come back to the original spot?
So negative K, 0, negative K.
No, not negative. If me do something, I have to half it back to where it was, boss. If the scale factor was 2, half it back. So the inverse of a scale of an enlargement of scale factor 2 is an enlargement of scale factor half. Right? We half it back. The inverse of enlargement of scale factor 3, you have to take back 1/3 of it. You have to 1/3 it back. And if my enlargement was a scale factor half, I'm a half something, I have to go double it back. So I have to apply back a scale factor of 2. So the inverse of an enlargement of scale factor K is an enlargement of scale factor 1/K. If my enlargement scale factor was 2, then my inverse scale factor is 1/2. Because I have a half back, I have to reverse that by half in it. And I have to use the same center. So my scale factor was -2, then my inverse scale factor is -1/2. -1/2. I'm going to invert it back to, this should have inverted it. This should have doubled it and inverted it. You have to go half it and then invert it back the opposite way. Forget it back. So the inverse of enlargement of scale factor 2 is an enlargement of scale factor half with the same center. It's common sense. There. The inverse of an enlargement of scale factor K is an enlargement with the same center and scale factor 1/K. 1/K. Right? So this was 2, then this should have been 1/2. If you double something, you have a half. If you triple something, you have to take back a third. You multiply something by 4, you have back a quarter. Simple as that. See there? So if K came from A, B to A, B prime, then 1/K, I will come back from A prime, B prime to A, B, the inverse. All right. And in fact, if you calculate the inverse of a matrix, look, if you have the matrix, 2, 0, 0, 2, and that's an enlargement matrix equal that, and calculate the inverse of that matrix, I guarantee you're going to get 1/2, 0, 0, 1/2. If you want, you can try it. So the inverse of this enlargement is this enlargement, because the inverse of this matrix is, by calculation, you're going to get that by calculation. So in the calculation telling you that it will be that. You can try it. You can try it if you want. Right? Try it if you want. Let's try it. What will be that? This time this, right? Which is 4 minus this time this. See there? So e to the minus 1 will be 1 over the determinant, which is 4 times the adjoint. Interchange these two. So you still have 2, 2. Leave these two where they are. Change the sign. Both of them 0, so you get 0, 0. And then divide each of these by a quarter. Right? And so you get 2 over 4, 0, 0, 2 over 4. Well, guess what? 2 over 4 is a half. 2 over 4 is a half, you know. So you get a half, 0, 0, half. That's what you get for the inverse of that. So that's it. Inverse of an L, and this will be an enlargement now of scale factor half. Whereas this was an enlargement of scale factor 2. And so the inverse of an enlargement of scale factor 2 is an enlargement of scale factor half. And it makes sense. So calculation give you, and common sense give you the same thing. All right, that is that. All right, enlargement area. All right, I think I'm going to start the next class with this enlargement area. Angular reflection. I'm not going to do this yet. I'm going to start by next class right here. The enlargement area. I don't want to. So let me show you what you need to study now, guys. Let me show you what you need. So you're supposed to study it for the first day. Let me show you what you need to be studying. Because you know that more maths equals better maths. And the must know sheet, where is it? It's supposed to be a best friend. This thing right here. It's supposed to be a best for the time being. All right. So what did I give you to study yesterday? This is what we did so far. Let me just do it from scratch. This is what we did so far, what we have done so far. What are the things you're supposed to study and know before? You're supposed to know translation. First one. Study everything in translation. Understand everything there. Translation. Now supposed to know enlargement. See there? So this is a summary of everything that we did today. That's what it says. So to describe an enlargement, you have to state the scale factor, which is the image length over object length, and also state the center point. Say that early. Also, the enlargement matrix is this. K0, 0, K. What it does is map a point onto a point K times, just multiply the point by the scale factor. Look, this is the enlargement area. Don't worry about that yet. This is what I was going to do a while ago. This is what is over here. This is what is over here. But we're going to start by next class with that. So don't worry about this part yet. You can study it still, but I explain it better next class. And look at what we said over here now. Give some examples of the factor. The scale factor is 2. Image is twice as large and twice the distance from the center and on the same side of the center. What I want to add now, pointing in the same direction. That's what I want to add to this. Pointing in the same direction. Pointing, let's see this. All right. Pointing in the same direction. So if you have it, you're going to add this to it for me. Pointing, same direction. Because of the positive. Pointing in the same direction. Scale factor is -2 now. The image is still twice as large, twice the distance from the center, but it is now inverted. So that nice word, inverted on the opposite side of the center. I'm going to add to this now, pointing in opposite direction, pointing in opposite direction, pointing in opposite direction. Also pointing in the opposite direction. So you're gonna add that to me for your slide for me. This one now, it is scale factor is a half, like I summarize what we did in the notes, you know. The scale factor half, the image is gonna be half the distance from the center, and on the side of the center because it's positive. and point in the same direction, pointing in the same direction, right? That as well, and point in the same direction, pointing in the same direction as well. Said that earlier, the image and the object will be pointing in the same direction because of the positive scale factor. And then down here now, the scale factor is over half, but I have to make it half the size, half the distance from the center, or the negative cause it now, cause it, the negative cause it to be inverted on the opposite side of the center. And further to that, they're gonna be pointing in opposite direction. They're gonna point in opposite direction. Opposite direction. The image and the object will point in the opposite direction. So you want to do the slide for me. The thing that you must know. Add this to it for me. I need to amend these documents and put these things in them. Pointing in the opposite direction. You're gonna point in the opposite direction. All right. So let me continue. You must know that. All right. What else you must know? This is reflection. It says reflection. I correct the spelling for me. I did reflection yesterday, so you must know reflection over here. You must know that as well. You must also know rotation. So these are the things that you must start study from now. You know, study them now on Wednesday. But you know, don't joke out the thing. Study them. All right. We did these two things today. We did two reflections over intersecting lines. Or the two reflections over parallel lines yesterday. Let's see what them say if we want to add to it. It says two reflections over intersecting lines is equivalent to a rotation with the center at the point of intersection of the two lines, and the angle is twice the angle between the two lines. Very good. And then we said for two reflections over parallel lines is equivalent to a translation. The translation direction is perpendicular to the two lines, and the size of the translation is twice the distance between the two lines. Good. All these things, if you know all things, the exam questions will be very easy. Trust me. Don't worry about this yet. We'll deal with that next class. So everything there that I put in red, you're supposed to start studying them. Don't joke around. Start studying them. If you know these things, the question will become very easy. Don't worry about this yet. I'll do this in the next class as well. Compound transformation. All right. Inverse transformation, yes, you can do this because this is like calculating inverse matrix. The inverse of a translation of a transformation matrix is just calculating the inverse matrix the same way. And the inverse matrix will reverse what the original matrix did. I will say that in for the most part, the inverse of the transformation, them common sense. All of them are common sense. All right, so leave this. When I deal with this in next class and spend a lot of time to understand this, you will not do a transformation exam and don't have compound transformation to deal with, and it is very easy. So leave that until the next class. All right, so your homework is to just watch over the videos. Two videos you're gonna have there now. Watch over the for revision, both of them, and these things. Start studying and knowing these things. That's work, guys. I'm gonna end it right there. I start back with this enlargement era thing tomorrow, Wednesday. All right, and we're gonna do examples. After we finish these, we're gonna on Sunday. Well, we're gonna do some exam Wednesday, some questions Wednesday now. Do this Wednesday. We're gonna do the enlargement era and the glide reflection. See, this glide reflection we're gonna do this on Wednesday as well. And then once we finish that now, we're gonna do larger questions on Wednesday. And then Sunday now is when I'm gonna Sundays when I want us to do. Sundays when I'm gonna let us do the class activity. I mean I should do the class activity first, you know. So maybe Wednesday we'll do some of the class activity and Sunday more. I'll decide what I'm doing. But don't when I finish it in good time though, don't worry yourself. Because it's online, I kind of have to be doing it a little bit differently than now. Because in the classroom, I will know exactly how I'm doing it, but because it's online, I have to be sort of varying the way I do it. But don't worry, we're gonna get through everything that we need to get through. All right, I'm gonna be masters of this topic. I tell you. masters, because this topic is the easiest topic in CSEC maths, because you can know the answer to the question without doing any work. No. All right, always stay. Body good?
Yes, sir.
Yes, Dad.
Beautiful, beautiful,
Yes, sir.
beautiful. That's what I like. All right, so just do your part now. All right, do your part. Study, revise, watch overs, use up everything that you have at your disposal. Or use up everything. Watch the videos. Any part of it, you don't listen to me again. I'm sure that I explain everything there. So listen back the video. All right, look over back everything. Anything about, send me a WhatsApp. Right, but I'm sure that everything will become clear after we start putting everything on questions. It's gonna become nice. Guaranteed. All right, so I'm gonna end it there for today, and we'll pick it up back on Wednesday. All right, I know this class will take a number of days to finish, but that's the nature of this topic. But done, we're gonna master it. All right, so don't worry yourself. But just do what I tell you in the meantime. Study those items, about the video, watch over the video, and you'll be fine. All right, by the time we get to questions, you'll be fine. All right, bye guys. See you all on Wednesday. Make sure
Hi,
that
Dad.
Yes,
Sir.
But any little pop question you Wednesday you can answer, you know, on the must know sheet, you know. Pop question on Wednesday. All right, beautiful. Sounds good. I like the confidence in that. All right, do what I'll be fine. All right, so see you all on Wednesday, guys. Bye.
Yes, sir.
Bye, Dad.
All right, cool.
Bye
Bye-bye.
bye.
Bye.
Bye-bye. Bye. All right, I'm gonna everybody know. Bye, guys.